In this video, we'll be going over a past paper question from 2023 GCSE Paper 3 for the Edexcel board. And this is the last question on the paper. So while this is a calculator paper, you don't need to use a calculator for this question, but it's some really simple probabilities brought together with substitution of values, ratios, and expanding brackets, with finishing off with simplifying and giving us the form our answer should be in. So this question is gifting us 5 marks that we can, once putting enough working out, we can easily get the answer. There is a total of Y counters in the box. There are X pink counters and 5 blue counters in the box. The rest of the counters are green. The ratio of X to Y is equal to 1 to 3. Frida takes at random 2 counters from the box. Find in terms of X an expression for the probability that Frida takes 2 counters of the same color. Give your answer as a fraction in the form ax squared plus bx plus c all over dx squared plus ex, where a, b, c, d, and e are integers. So we've written out our ax squared plus bx plus c all over dx squared plus ex as a way of seeing what our answer should look like at the end, so we can keep referencing back to this. So the first thing that we're going to do is we're going to find out what y is in relation to x, because our answer at the end only has values in terms of x and we don't have any y values. So we're going to find out what y is in terms of x. And so what we're going to do is we're going to use our ratio here. So x to y is 1 to 3. And this gives us our ratio total as 4. So out of the total of x and y combined, even though x is a subset of y, we can see that x is 1 over 4 of the total and y is 3/4 of the total. 3/4 is equal to 3 times 1/4. So we can show that y is equal to 3x. Now this will be useful later on. Now we're going to find the number of each counter. So we're already told in the question, x is the number of pink counters, 5 is the number of blue counters, and the rest of the counters are green, with y being the total number of counters in the box. So we'll have our pink, blue, green, and our total. So we know that the number of pink is x, which can remain as x. The number of blue is 5. And the total is y. Now from this we can find the number for green, which is just our total minus the number of pink plus blue. So that'll be y minus x minus 5. So these are the numbers of each counter. Now we can start finding the probabilities of taking 2 counters that are of the same color. So we can write 3 different probabilities for this. So the probability of taking 1 pink and then another pink. And then we'll have the probability of taking 1 blue and then another blue. And then the probability of taking green and then another green. And as far as we know, both of these counters are taken at the same time, so there's none of the counters being replaced. So let's start off with our probability of getting 2 pinks. So the number of pink counters is x, and this is out of y, so that's the probability of taking 1 pink counter. And then taking another one, because it's not replaced, it will be x minus 1 over y minus 1. because this takes into account that you've already taken a pink counter, so the number of pink counters has decreased by 1, so that's our x minus 1, and then the total number of counters has also decreased, which is y minus 1, because we've removed that pink counter. So that's how we get x minus 1 over y minus 1, and when we multiply it together, we get this as x times x minus 1 all over y times y minus 1. Now we can find the probability of getting 2 blue counters. So the number of blue counters is an integer value, so that will be nice and easy for us to do. The probability of finding our first blue counter will be 5 over y. And the probability of finding our second one will be 4 over y minus 1. Now this follows the same logic as we have applied for the 2 pinks. And this gives us 20 over y times y minus 1. Now we'll move on to finding the probability of 2 greens. So we'll take our value for the number of green counters, which is y minus x minus 5 all over y. And we'll multiply this with the probability of getting another green counter, so it'll be y minus x minus 6, which is 1 less. So we just subtract 1, and this will be over y minus 1. So now what we can do is we can now substitute our y equals 3x into all of our probabilities here. So what we want to do is we don't want to simplify any of our fractions, because we don't want to lose our denominator having the form of our x squared plus x with our coefficients of d and e. So we'll substitute 3x in the place of all our y's. So we'll start off with the probability of 2 pinks. So we'll have x times x minus 1 all over 3x times 3x minus 1. This simplifies down to x times x minus 1 all over 9x squared minus 3x. So in this scenario, we don't simplify our fraction here, because the other 2 probabilities that we have will have the same denominator, and keeping the same denominator over all 3 fractions will make it easier to deal with later on in the question. So for our probabilities of 2 blues, we'll have this is equal to 20 over 3 times 3x times 3x minus 1, and our denominator remains as 20 over 9x squared minus 3x. Now for finding the probabilities of 2 g's, we have to substitute our 3x into our numerators as well as our denominators. So we're left with 3x minus x minus 5 all over 3x times 3x minus x minus 6 all over 3x minus 1. Now our numerators can be simplified, so we get 2x for both. So we have 2x minus 5, and this will be multiplied by 2x minus 6. So we're bringing our 2 fractions together now, and this will be over our denominator, which is the same as the previous 2, 9x squared minus 3x. So there's no change in that. So what we can now do is we can bring together all 3 of our fractions. So this will be the total probability of taking 2 counters of the same color. So we'll have our probability of our pinks plus our probabilities of taking 2 blues plus our probability of taking 2 greens. Now we'll join all our fractions together. So we'll have x times x minus 1 plus 20 plus 2x minus 5 times 2x minus 6, and this will all be over 9x squared minus 3x. Now we're going to start expanding our brackets. So our fractions now will be x times x will give us our x squared minus our x times minus 1, so that's our minus x, plus 20. And now we're going to expand out our two brackets for green. So we'll have 2x times 2x, which is 4x squared. 2x times minus 6 is minus 12x. Minus 5 times 2x is minus 10x. And minus 5 times minus 6 is 30. And this will all be over our 9x squared minus 3x. Now we can start bringing together all of our like terms. So we're going to start off with our x squareds. X squared plus 4x squared gives us 5x squared. Minus x minus 12x minus 10x gives us minus 23x. 20 plus 30 gives us plus 50. And this is all over our denominator of 9x squared minus 3x. Now if we go and look at our question again, we can see that our answer is in the form of ax squared plus bx plus c all over dx squared plus ex. Now if we go down, we can see that all of our coefficients, so a we have as 5, b as minus 23, c as 50, d as 9, and e as minus 3. All of these values are integer values because they can be written as fractions, and so as their whole number values. And so our answer that we've got here is in the format that the question asks for, and so this is the probability of getting two counters of the same color.
As always, thank you for watching, and make sure you subscribe so you don't miss out on any new content.